Okay, so on this next one, it is not yet in standard form. So what I want you to do is distribute to get x squared plus 2x. And now we're going to put it in standard form by subtracting 6x from both sides and also adding 11 to both sides. So that successfully gets me 0 on the right hand side. On the left, I'm getting x squared minus 4x plus 11. Then I can determine what my a, my b, and my c are once it's in standard form. So a is equal to 1, b is equal to negative 4, and c is equal to 11. So x equals negative b plus or minus the square root. Writing out my formula again to remind myself what the formula is. X equals negative b. Well, my b is already negative 4, so the opposite of negative 4 is positive 4. Do the b squared in your head. Negative 4 squared is negative 4 times negative 4, which is positive 16. Anything squared should end up to be a positive, so your b squared should always be positive. Minus 4 times a times c. A is 1, c is 11, all over 2 times a, which is 1. Let's carefully work out underneath the radical. There is only one negative, so that's going to stay negative. 4 times 1 is 4, times 11 is 44. And 16 minus 44 is negative 28. So on this side, negative 28, I can reduce that radical. 4 times 7, 2, 2, and 7. So I have 4 plus or minus. The 2 comes out. The negative comes out and becomes an I. And the root 7, he's all by himself. He has to stay home. I'm going to factor 2 out of the numerator. And the 2 and the 2 divide out nicely. So my final answer is 2 plus or minus I square roots of 7. On our last problem of this type, we're going to distribute to make this into standard form. So I get 3x squared plus 12x minus 2x minus 8 equals negative 7. I'm going to combine the two terms that are like on the left-hand side, which gets me 10x positive. And at the same time, I'm going to add 7 to both sides to get minus 1. So my a, b, and c are a is 3, b is 10, c is negative 1. I'm going to plug it into my formula. X equals negative b. b is 10, so the opposite of 10 is negative 10. Plus or minus the square root of b squared. 10 squared is 100. Do that part in your head. Minus 4 times a times c. My a is 3 and my c is negative 1, all over 2 times a. Then I'm going to carefully work the inside of the radical. A negative times a negative turns out to be a positive. So we have 100 plus 4 times 3 is 12 times 1 is still 12. So we have negative 10 plus or minus the square root of 112 over 6. I think 112 we're going to reduce here. If it's too big for you to factor out, it's even, so at least divide by 2. That gets me 56. 56 is also even. That's 2 and 28. So it's 2, 2, 2, 2, and 7. So 2 groups of 2 come out. So that's 2 times 2 are 4. So we have negative 10 plus or minus 4 comes out. The 7 stays home. It looks like I can factor out a 2 out of the numerator. And that gets me negative 5 plus or minus 2 root 7 over 6. And now the 2 and the 6 can reduce to the 3 in the denominator, which gets me a negative 5 plus or minus 2 square roots of 7 all over 3 as my final solution. So we have just covered all four methods of solving quadratic formulas: factoring, square root method, completing the square, and quadratic formula. And each time we told you when you could use it. But I want to just review that because at some point you're going to be able to choose which method you want to use, and you need to follow this order. Step 1. Always try to factor first. Now, if you can factor it, you should be able to factor it within the first 30 seconds. If you're taking more than 30 seconds to factor it, stop and move on to the next method, okay? Factoring is just really simple and fast, but if it's taking too long or if it doesn't seem like it's going to factor, then move on to the next method. Step 2. If b is equal to 0, or if you have it in the form expression squared equals a number, then you can use the square root method. If b is equal to 0, then it's easy to put it into the form expression squared equals number, and you still use square root method. Step 3. If a is equal to 1, and if b is even, then it's really easy to use completing the square. Now, if a is not 1 and b is not even, you can still use completing the square. But in my opinion, if a isn't 1 and b isn't even, or if I can't get it like that pretty quickly, then I would probably abandon that method and move on to step 4, which is, as a last resort, use the quadratic formula, which will solve any quadratic equations. So even though completing the square will and quadratic formula will also complete all or any quadratic equations, I would probably use completing the square first if a is 1 and b is even, and then as a last resort use the quadratic formula. So this is how I choose which method is quickest, fastest, and will get me the correct answer in a minimum amount of time. So I hope this summary helps you when you're trying to decide which method to use.